Entry angle and view angle. These are much less well known. And as you read the guidance that's out there in our NCRHP 672, the Federal Highway Roundabout Guide, and other guidance, it's difficult. It doesn't jump out at you and tell you which one is most important. Okay. Here's an example of a skewed intersection, which has much greater than 90-degree skew. Also has speed control issues associated with it for both the through movement and the right turn pass. And so as we begin to optimize this design for safety, we look to square up that intersection, and look what happens. So we square it up. It's not perfectly 90, but it's a lot better than it was. There's lots of constraints here that we're balancing. And our entry angle, referred to as phi angle, now meets the standard and principle. And our view angle to the left is met as well. In addition, our speed control is much better, which will improve both vehicular to vehicular as well as improve the environment for pedestrians and all users, bicycles as well. So here's the first optimization example, case study. This is in Ohio. Project I was asked to be involved with. We look at the original design. It has a high view angle. Okay, it's 17 to 20 degrees. We like it to be closer to 10 to 12 degrees. And when these entries are flatter, it looks more like a merge condition, and you get people have less yielding behavior, and they have more, merging behavior. I was going to say merging behavior, so that doesn't work. Prior to confusion, who yields to whom is also confused with the flatter angles. So it's about 17 degrees in the southbound direction, about 20, particularly, so it's measured in the outside lane looking back to the left, 17 degrees off of 90. In addition, the phi angle, which is something that's confusing. It's not really, it's mentioned in our NCRHP 672 guide. It's mentioned more strongly in other design guidance that's out there. And that comes from the UK. But so meeting the phi angle and the view angle is important. So in this particular project, we have circuitory widths that are equal distance. Okay. So one thing that we can do, and here's a project that we did this to, as we are going to propose here in this project, is we take that inside lane on the circuitory roadway and make it 10 to 12 feet. Okay. Well, what that does, and then the outside lane becomes much wider. It improves a lot of things. Okay. Well, just so we're not changing any curbs with this project, all we're doing is we modified the circuitory lane line placement and the yield line placement slightly, and we're able to affect the view angle pretty substantially. Okay. Signing and marking. There's a tendency and an easy to over-sign multi-lane roundabouts in urban conditions. We end up with information overload, and that can be problematic. We know that from all our industry, but we end up with a lot of signing typically at urban multi-lane roundabouts. Here is the Ohio project that started off. It looked like this on the approach. Lots of information going on in a short period of time. And we proposed changing that to try to clarify and simplify the decision making. And that's what it looks like today. We changed the official style arrows to standard arrows. We used the R16 style pedestrian signage, which is based on some research for that signage, to try to provide height variation to signing to improve target value for all signing at this project. And use conventions that drivers are used to as opposed to conventions that drivers aren't used to. In addition, the operational analysis showed that we didn't need all that laneage. So we could reduce the conflict points as well. So we open it back up as a 2x1 roundabout, making that outside turn lane a right turn lane, making some curb line modifications. And that will last most of the design year of this project based on the traffic projections. But we also have a phased, you can then bring that back to the 2-lane roundabout when capacity is necessary.